Hi, this is John Anderson. I'd like to welcome you to Enhanced Content for Common Engineering and Technology Courses, Module 1. This course, of course, is sponsored by C2Gen and is based on material that was developed under the Aerospace Manufacturing Education Project. Both of these are National Science Foundation sponsored projects. So, with no further ado, let's get started. This is going to be a voice over PowerPoint asynchronous course, and we'll talk more about that as we get into it.
So again, this is Enhanced Content for Common Engineering and Technology Courses, Module 1. And let's dive into it. The Aerospace Manufacturing Education Project came about as a collaboration between industry, people like Lockheed Martin, Boeing, and Northrop Grumman, and academia in the Purdue University, Oregon Institute of Technology, and El Camino College. Our goal here was to try to interest students in community colleges and in the first 2 years of engineering programs, typically in universities, in considering the manufacturing sector of aerospace as a career choice. It's not very hard to get a freshman engineering student, for example, interested in designing modern jet fighters, high-performance jet fighters. But it's a little harder sell to convince them, to get them excited about actually going in and building these on the factory floor. So how do we go about doing that? Well, our methodology was to create modules for use in common courses. Why that as opposed to doing discrete standalone courses, say a 3-hour lecture course on aerospace manufacturing? Because those have to go through a curriculum committee, and typically you have to have some sort of champion on the faculty at each individual school. That's very tough to do. So what we chose to do instead was to use the common courses that are already out there, such as the overview of materials that almost everybody in technology takes during their first couple of years. And we wanted to do these modules in blocks of 1 to 3 lecture hours to cover a specific topic. We used PowerPoint and Word files so that you can take any of these modules and separate it out, mix it and match it with materials that you've already developed, or change it. And our hook in this is that we used examples from aerospace manufacturing in the presentation, in the PowerPoints, and in the student activities. So we offer an interesting and current presentation of materials for that particular section for the course that we're targeting. And why should educators want to use this material, other than the fact that hopefully it's interesting and it gets some additional student interest? Well, it also helps them reduce their prep time. We have in the instructor notes, in Word format, we have lots of URLs for videos on YouTube, for manufacturers of components, so that you can use those for student activities or to enhance the lecture portion of the course. So these materials are captured in the Aerospace Manufacturing Education website. That is aerospacemfg.org. And this is the front page of our website. When you go onto this website, it asks you to register. You won't be getting any sales presentations if you register. The reason for registration is that since we're sponsored by the National Science Foundation, we have an obligation to report back to them on how successful our work was. And one metric of that is how many people have signed up and which modules did they download. So by registering, it just helps us keep track of that. Once you get into the Aerospace Manufacturing Education website, you'll find you have access to what we call public modules. These modules are set up into 4 different folders: composites, fasteners, assembly, and materials. Why those areas? Well, when we first started our project, we went out and interviewed over 150 new engineers or technicians that were working in aerospace manufacturing. That is, guys with less than 2 years of experience in industry. And we asked them, what surprises did you find when you went to work? How well did academia prepare you for what you're doing? If you could add stuff into your educational program that would have helped you hit the ground running, what would that be? And so we took all of that material and we boiled it down and came up with these 4 areas. And typically the responses we got from these young engineers or young engineers and technicians, was around the specifics for aerospace. So in materials, they typically got a good overall understanding of metals and maybe plastics, but not much time was spent on composites, or not much time was spent on some of the exotic aluminum alloys that aerospace uses. And so we wanted to do some things in the materials area. We wanted to spend a lot of time in composites. That was the number one thing that these folks told us, is that they didn't understand the terminology and they didn't understand the concepts of composites. In fasteners, it was particular things, typically, at least for engineers, mechanical engineers, the extent of their fastener education is sizing bolts in a machine design class. And so we wanted to go and explore a lot of the different types of fasteners that are required in aerospace because of the way you have to assemble the airplane. And of course that gets you into assembly also. So fasteners and assembly sort of overlap, and we'll cover those together when we talk through this material. So what are our objectives in this course? Well, we want to introduce you guys, the instructors, to the materials available on our website and some of the methods to integrate them into your classes and where they fit. We want to present an overview of composites. So we'll spend more time on composites than any other one section. We want to offer you guys an overall introduction into the materials we offer in the area of materials and in the area of fasteners. And we want to demonstrate last an organized, affordable lab kit that's not facility dependent. We'll talk more about that in a minute. Our format on this class is going to be asynchronous. That means I've prepared all the materials ahead of time, and once the class starts, then you can access those. And you can work at your own pace. The downside is that you won't be able to access me to ask questions or your classmates. I will post my email address, and so if you run across a question or a comment you'd like to email me, you can do that. I will be traveling some during the time this class is offered, and so I may not get back to you immediately, but I'll try to check my email as much as possible. Modules generally contain a video of approximately 20 minutes, student activities, that is your activities, that will take approximately an hour to hour and a half to complete. This may be watching other YouTube videos. It may be looking up material online or selecting raw materials. It may be reading material. So each class in this course will have a set of student activities, and that'll typically be in Word format. So if it's a video that I ask that you go look at, a YouTube video, for instance, I'll have a URL set up so it'll take you directly to that. And last, the self-assessment exercise. I say self-assessment. It'll be an assessment of what you've learned plus an assessment of the module or the class itself. Now, the exception to this format is this particular class that we're in right now. We will not have student activities for this. This is sort of an introduction. This is to tell you what it is we're going to talk about for the remainder of this course. So we have 10 modules, the course introduction, which is what we're doing right now. We have an introduction to material on the AME website. We'll go through how do you log in, how do you register, how do you navigate the site. I'll make some suggestions overall on how I think you should use the materials. And we'll talk about interesting modules that are out there that don't exactly fit into any one category. Next is fasteners. We have several modules on fasteners on our website. So I'll take you through an introduction to all of those modules, what each one is trying to convey to the students, and how best to use those. Same idea for aerospace materials. There are several modules that are very interesting in there and that fit into a wide variety of classes. For instance, we're going to spend some time talking about the failure modes. I think that the exact title is Aerospace Failure Modes module. It's interesting because it has catastrophes. You know, it has airplane crashes and it has wings shearing off of airplanes and things like that. What we've done is gone through and taken the common failure modes and we've illustrated that in aerospace applications. So it's interesting stuff. It's great eye candy on the PowerPoint, but it also goes back and reinforces this design, the idea of designing to prevent failure. And so it would be interesting in a material selection course, for instance, or in something like machine design, first machine design course, or strength of materials course. Next, for the remainder of the course, actually, we're going to talk about composites. We have 3 different sections on composites. First is an introduction to composites. This module covers materials and basic methodology. It talks about resins and curing and the impact of heat on curing and all of this stuff, the basics of composites, an introduction to composites. We're going to take 2 classes to complete that introduction to composites. And then we're going to talk about industrial manufacturing of composite parts. And we're going to take 2 sessions to complete that. And last, we're going to talk about composites labs. We've gone through and designed some laboratory exercises for composites that use a kit that we specified. And this is a kit. I want to spend a little time on this module talking about this kit because if you order it now, then if you choose to buy it and you order it now, you should have it by the time we actually cover the composites lab as the last two courses, last two classes in this course. Now, you don't have to buy this. This is optional. You can watch those two modules, and we'll have some student activities that you can go through in lieu of having the lab kit, or you can order the lab kit and you can actually make these parts as I'm making them. We'll have videos of actually making parts, and you can make parts along with me. So the advantage here is that if you're planning to use this composites lab kit in your classes, you'll have already been through it and you'll have some hands-on experience. There are two ways of buying this kit. Oh, by the way, the kit is actually available from a company called Aircraft Spruce and Specialty Company. This company specializes in supplying materials for people who build experimental airplanes. So the URL, the web address for this company that'll take you directly to the practice kit is aircraftspruce.com/catalog, blah, blah, blah. You can see that here. Whoops. There's also, there's three ways of buying kits, or three kits that they have listed here. The first, I can't keep from switching back and forth. The first is a kit for $60. It's called the International Kit. That's not what you want. The other two kits are with or without an optional book on composite fabrication by Burt Rutan. Without the kit, or without the book rather, the kit is $95 roughly, and with the book it's $110. So I would suggest, if you choose to buy the kit, that you invest for this course, that you invest the $15 to get the book by Burt Rutan. Burt Rutan, for you guys who don't know, designed the Voyager aircraft, the first aircraft to circle the entire globe without refueling. He also designed the Space One aircraft, the one that won the prize for the first commercial spacecraft and went into space twice within a couple of days. He was actually partnered up with the folks who were doing the commercial space trips, orbital space trips that had the rocket plane crash recently. So anyway, Burt Rutan is a very, very, very smart guy, one of the most influential airplane design guys in history. His book is very interesting. It's very practical. It's down to earth, and it's written specifically for people who are building their own airplanes. It gets down into the weeds on what techniques do you use. So I highly recommend that. So you could choose to either buy the $95 kit or the $110 kit. I would suggest the $110 kit. When you buy this for your students, if you're going to use this in your courses, it's a little different deal. One of these kits will service maybe 10 students for a range of experiments throughout a course of materials, say 3 experiments, and it doesn't make a lot of sense to buy the book if you can't give one to each student. So anyway, this is where you get the kit from. They accept credit cards, and you know how to do it. Go there and order the kit if you're interested. Like I say, I want to stress this is an optional kit. You do not have to buy this. So that brings us to the end of Module 1. And I look forward to talking to you guys on the next 9 modules. Thanks.